In this video, we are going to do a scientific method activity. It's going to be a lab demo. And what we are going to do is investigate the scientific method in regards to surface tension, the surface tension of water. And water has a pretty high surface tension, and surface tension just means it's the water's ability to stick to itself. We're going to end up measuring it by adding drops of water drop by drop to a penny. And then we're going to count how many drops it will hold. If you went into Google and did a Google search for surface tension of water, you would see some pretty cool pictures, like this one here of an Olympic swimmer. You can see as he's emerging out of the water, his body is like enveloped in that water because it has a very high surface tension. Basically, it's sticking to itself and to him. So we're going to do a lab about that and about the scientific method. So this first thing, initial observation, it says observe surface tension by seeing how many drops of water can fit on a penny. And it asks us to count the number of drops. So that's going to be the first thing we do. Okay, so I have my penny here, and I'm just going to start adding drops, and we're going to count it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Alright, so it spilled at 31, which means it held 30. And as I was doing that, you could kind of see the water building up pretty good on top of this penny. So give me a second, we're going to record that. Okay, so I think what we said was the total number of drops there was 30, because at 31 it spilled. Now, it's asking us to make a hypothesis. The hypothesis, remember, is an idea that you can test. And really what we're going to do, well, we're going to look at this question here, because the first part of the scientific method is coming up with a question. We want to know, how does soap affect the water surface tension? So really you have three possibilities for a hypothesis. Either you're going to say you think the soap will increase the surface tension, so you'll get more drops of water on a penny, or maybe you'll think the soap will decrease the water's surface tension, which means you'll get less drops of water on the penny, or maybe you'll think it has absolutely no impact whatsoever on the surface tension. So what you want to do is right now is make a hypothesis. Is it going to increase, decrease, or have no change on the surface tension? So what you want to do is pause this video, think about it, make a hypothesis. And what I'm going to do then is do 2 more trials with this tap water, because what I did right now was tap water, and this first trial is what we have up there. That was 30 drops. I'm going to do 2 more trials where I do the same thing, just adding drops of water to a penny. Okay, this is trial 2 of the tap water. We're going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Alright, so it's spelled at 36, so we're going to record that as 35. So we can bring our lab paper back. Right here we got that as 35. So I'm going to set it up and do 1 more trial of that. Okay, I did 1 more trial doing the same thing and save you the trouble of watching it. But I did the same thing and it turned out to hold 32 drops of water. So now what we're going to do is 3 trials of soapy water. Okay, here's my penny again.
I have soapy water in my medicine dropper now. So we're going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, started spilling at 22, so I'm going to mark that down as 21. Now I'm going to end up doing the same thing 2 more times with soapy water. I have another penny here that's nice and dry, so I can do that now. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Alright, started spilling at 21, so I would write that down as 20. And now I'm going to do this one more time, and then we'll start getting some averages. Okay, so I did one more trial with the soapy water, and it came out to be 18 drops. So I averaged these out, so to average them, I just took the 30 plus 35 plus 32, divided them by 3, and I got 32.3 drops as the average for the tap water. For the soapy water, I did the same thing. It came out to be 19.7 drops as the average. So, why were many trials taken and averaged? Well, you can see that there was some variety between those. There's a little bit of change. And it also tells you up here, because water drops may vary depending on how well you drop the water, how hard I would squeeze the bulb, for example. Right, the bulb on the eyedropper. Sometimes you might get bigger drops and smaller drops, so it's good to do a couple trials for that, just to eliminate any of those differences. But for these, they're actually pretty consistent, I think. All right, now you're going to end up having a form to fill out, and it's going to go along with these questions. In this experiment, what was your control group? Identify the independent variable in the experiment, and identify the dependent variable in the experiment. I'm not going to give you any hints with this because I want you to go back and check the notes. If you don't remember what all of those things are, check the PowerPoint that's posted or the notes that you took. You should be able to figure those out pretty easily once you realize what's being asked there. And then the last question, how does soap affect the surface tension of water? How would you answer this question after completing this activity? So there's going to be a form for you to fill out with those couple of questions, but then that is it for the scientific method lab demo that went along with surface tension. Thank you for watching.